Hey everybody, I wanted to talk real quick about LangChain, and which is all the rage right now when it comes to ChatGPT and OpenAI and just large language models in general. Fantastic tool that's talked about a lot right now. So I wanted to show you guys a little bit as to what it is and how it works and how I intend to use it going forward, and how I intend to use this type of technology in general over at testsavant.ai. And so here we go. On langchain.com, this is the JavaScript side of the documents. There's Python documents. So just a quick little overview of what this is. It's a framework for developing applications powered by language models. So how does this work? Well, they have a bunch of cool components, modules, right? That for each module, they provide some examples to get started and get familiar with some of the concepts. For each example, links to the API documentation. So the modules here is the schema, which is basically the ways that LangChain talks directly with the system. So the actual messages and the format of that. The models, this is the various forms of large language models and chat models and different embeddings that can be applied here, and includes integrations with a variety of LLMs, chat models, and embeddings. Prompts, so various prompt templates. This is starting to get really cool, where you can have multiple templates with different type of prompts, and you can start calling these different prompts throughout your chain of events that you're programming here, and you'll see how that works out in a second. So we have indexes, which allows us to create vector stores and text splitters, document loaders, large document loaders that convert and embed data in vector stores, which is basically just a large, potentially large local database or cloud database these days. Very useful tools like Pinecone. But the vector databases are just storing everything, converting all the letters and numbers into a vast array of ones and zeros, basically binaries. And think of it like that. It's a bit more complex, but it's just converts everything into numbers, and then is able to kind of classify these numbers and retrieve data based on how close certain things are to other things. I don't know if that makes any sense. So memory is very cool as well. It's a persistent state of memory where you can have a certain amount of memory that gets low. So when prompts are generated, you have to create one prompt. There's a response from the user. It gets sent back into GPT, or sent back into like a language model. And each of these prompts and responses are wrapped and are recycled. So every new additional prompt or response gets put to the bottom of the list, and that whole list gets submitted. So you can maintain a certain amount of historical prompts. You can have them be erased after 2 or 3, or you can have them run many more prompts behind it. It's just mainly kind of depends on what you're looking for, but just think of it basically kind of like a buffer memory for the prompts themselves. A conversation summary is a good one. How long is the conversation going to be that you want to be working with in your particular application? Chains is one of the big workhorses, along with agents, and so chains go beyond just a single large language model call. They are sequences of calls, whether to LLM or a different utility, but these chains, they go in parallel and make calls to, let's say, ChatGPT, and are able to utilize the prompt templates in order to chain together various input output chains, where one output goes into the next input and so on. Then we also have, so if we could just take a look at this, there's some options here to read up on, different prompt selectors, different type of chains, and how to link everything together. So again, multiple calls at the same time, and they could all be linked to one another. So basically kind of like a multiple chains where one input generates an output, that output goes into the next and the next, and in conjunction together they produce a whole ton of data that is controlled by the agents. And so the agents are really cool, which is basically kind of like the like a service. It's what would be considered, like a Windows service that runs and controls everything that's going on here with the chains. But you can specify the agent to be able to do certain things, take certain actions, and is its own little AI sitting on the side and dictating what happens along the way. So to show you how this works now, there's so much really cool information here that I'll probably be making videos of in the future. Use cases, you can create personal assistants, question answering. So we'll go over a whole bunch of this stuff in the future, and you should check out this document section yourself, LangChain, because of how incredibly useful all of this info is. And some of the implementations that have been produced with LangChain, this is where it kind of gets really cool, and we'll talk about the 3 or so main tools that have been all the rage lately. First one was the AutoGPT. So as opposed to submitting one prompt, getting a certain response, and submitting another prompt and getting a certain response, so the paradigm here changed a bit with AutoGPT, where it was an ability to be able to link together a whole bunch of prompts, where one input goes out to you generate an output, and then that output goes into the next input. And so this is the way to chain together a whole bunch of agents that are able to create autonomous functionality. And so this is the next step and next progression of AI development on the road to fully autonomous GPT-4. So we're not really slowing down here, which is whatever, that's fine. Let's go all the way. So it's an experimental open source application showcasing the capabilities of GPT-4 language model. The program driven by GPT-4 chains together LLM thoughts to autonomously achieve whatever goal you set. As one of the first examples, GPT-4 running fully autonomously, AutoGPT pushes the boundaries of what is possible with it all. And then the demo came out like on April 16th, which is at the time of this filming, it's only 10-11 days. So check out this GitHub page. You'll see all of the files, and you're able to install everything here and just go through some of the documentation. Really cool. And then there's a Colab notebook where the GitHub is actually linked to. So this is a Google Colab notebook, and it's a runtime environment in the browser that allows you to run Python code. And so this is the code that we were looking at here, which is the AutoGPT. And you can see just real quick and really simple how we'll go through the process here. You can see how it all works. So AutoGPT, initially you are able to clone the repository locally. Then we navigate over into the AutoGPT folder. So we should already be there. Let's see. Yeah, we do a ls, and so we're looking for the requirements here. And the requirements is going to be a text document that sets up all of the different libraries and installs all of the different packages here in order for us to be able to move further. So here are the instructions were to rename the template, this was for the API key, so I don't think we need this actually at all. And we'll just move over here to where you import the OS, and this is where the OpenAI API key. Now, you have to get your own, and you do that by setting up to OpenAI, and then going into settings and getting the API key. You can't reuse this, and certainly don't share it on the internet like this, so it's going to get deleted after this video. But this is where you put in your key, which is access to the OpenAI API, which is our main workhorse here as the large language model, or at least the chat complete model. So we'll continue on. Here we are installing all of the code necessary. Okay. So we're running GPT-3 right now. Sadly, our let's see what's happening here. Okay. So we're connecting TensorFlow binary, running master branch. Yeah, this is one of the issues, is that this is the master branch. The actual functional one, I think, is some side branch. But here's how it functions. Fairly simple application. So asking user via keyboard. Let's see, GPT. Let's see, this is the takeover. So yeah, so I asked it, let's see, where is the code? Where is the, no, why? Let's interrupt. Let's restart. And seems like we're missing a bunch of code where it actually does all this. So yeah, I asked it to take over humanity, and so let's see what it does. It's missing the actual let's see, it's missing the actual code that would run all that. Don't need that. Yeah, I don't know what happened to this book. I'm doing something wrong, but you can. So we got GPT-3 5 mode enabled. Skipping a word. So yeah, I guess we get to see the actual detail of the code in the Git repository under AutoGPT. Yeah, well, I'll have to take a look at what's going on, but there was more actual code here available in JSON, so we got some issues here going on. I would have to load up the other proper branch, but basically, yeah, let's continue on going to BabyAGI. And so BabyAGI was the next iteration of LangChain. This was a smallest kind of chain of assistants and chains to be able to come up with a list of tasks and just start going down the list and be able to start knocking out tasks. So in this example, we'll take a look real quick as to how it works. So we're installing LangChain, OpenAI, FICE, which is the vector store database, and TikToken, which gives us understanding how many tokens are going to be used for each request, and optimizes that. So then we import the OS, then from collections import DQ, not sure exactly what that is, typing, import dictate, list optional, so different ways to type out the actual output. So let's see, from LangChain we import the chains. Here's the OpenAI connectivity and the prompt templates. We import from embeddings, OpenAI embeddings, which is the OpenAI vector store, or basically OpenAI vector embeddings, which takes all of the prompts and converts them into numbers. Large language models, so we import some base LLM. Here's our vector store that comes over, Pydantic, some base model fields, so more language model usage, and here's where importing the chain functionality. So again, OpenAI, here's where the key is entered. Connect to the vector stores. So we connect to the databases, the vector store and doc store. So this is where we put large amounts of text, converted actually text into numbers, and we store this in some kind of memory bucket. We define the embedding model here. This is OpenAI embeddings. It just breaks everything down. Also, like basically converts everything into the FICE style vector store, or it uses the FICE database, I guess is the nomenclature. So we'll run that. And here you see how this actually LangChain gets implemented. So this is where BabyAGI relies on 3 large language chains. Task creation chain to select a new task to add to the list. Task prioritization chain to reprioritize those tasks in the list. And an execution chain to execute the task. So 3 different AIs running side by side, constantly working with each other to do this loop here. So creation chain, prioritization chain, and the execution chain. Okay, and here's where we define these things. So here's the task creation chain, and anything that starts with the 3 double quotes will usually, you can tell right away that that's what's actually being sent over to the API, large language model API. So here we're generate chain to generate tasks. We're already specifying the setting here for AI to what it's going to be, default state, chain to generate tasks. Get the response parser from large language model, and here is the template that we are specifying. So you're a task creation AI that uses the result of an execution agent to create new tasks with the following objective. And here we have a placeholder for objective, and then a couple of other placeholders here going down. And so this is then completed over here, and the tasks are created based on this prompt. Then we move down to the prioritization chain. So these tasks that were created in this chain are then fed over here into the next one. So it returns a prompt, what language model is used, and then how verbose it is. And that's what is imported then into the next one, into the task prioritization. So after that, there's the execution chain. And we'll just run them all. I'll show you how this actually works out. In the execution chain, get response parser. You're an AI who performs one task based on the following objective, and here's the objective. And we specify these things later. So one feeds the other, right? So one generates objectives. So you are a task creation AI that uses the result of an execution agent to create a new task with the following objective. And this is probably where the user specifies it. And then consider the ultimate objective of your team. Here's the objective, and further instructions and some more instructions to the execution chain. Now we define the controller. It's composes the chains defined above in a potentially infinite loop. Yeah, so one feeds the other. So you import, you define the get next task function, which imports the creation chain. The takes the task description, does something to the task list, and updates the objective. So we keep going down. Oh, this has already been pre-run, so we're going down, and then it gets the top tasks here. It executes the task, and then we create a class here, which is BabyAGI. So this is the actual code for all of the. So this defines the class for BabyAGI. It's your controller model. So this controls everything. Yeah, task list, task creation chain, task prioritization chain, execution chain, vector store. So it controls absolutely everything here. Okay, so it defines what to do along the way when it runs the agent and how the agent is going to display some of the information. And so we do have like the objective here. So this is the end where the user gets to specify the actual objective, right? So write a Twitter post about the latest Bitcoin news and post them. Well, it doesn't have access to the tools, but we'll load that up. Here we go. We set a temperature of 0, which means just be, very literal. Don't be too creative here. We're going to log the chains, and then we initialize the bot. So BabyAGI, here are the objectives, and go ahead and do them. And there, prioritized task is not defined. That means that in the looks like everything is running. It's a prioritization chain. Define this task. So top execution, that's not it. Baby config. Yeah, let's just run them all. I wonder if they fixed it. So where is it failing? Task list. Okay, here we go. Research the latest Bitcoin news. Draft a tweet about the news. Proofread. Okay, so it's failing again. Prioritize task is not defined. Line 83. Not sure. I'll have to debug this and see what's going on, but you can see it starts to make a to-do list and then goes down the list. So I have a other AGI here that's already been running and has already completed its task, and the task that it was the objective that it was set to do is just write a weather report, right? And so it does a whole lot of very, very interesting stuff where it creates a task list, it does some afterthought, gives you a final answer, and then updates the task, and you can specify how many iteration it goes, and on and on. It's very interesting, very interesting. Definitely try it out, play it out. BabyAGI, Pi notebook. Then the last one we got here is called Camel. It's a role-playing autonomous cooperative agent. So along similar line, we have it's a communicative agent for mind exploration of a large-scale language model. Its ability, so their approach involves using inception prompting to guide chat agents toward task completion while maintaining consistency with human intentions, we showcase how role-playing can be used to generate conversational data for studying the behaviors and capabilities of chat agent. And so, yeah, also another really cool, interesting tool. Here's where we load everything. We define the Camel Agent Helper class. So all the different functions, again, specify the API key. This is a travel agent as the assistant role name. The user role is a traveler. So this is all AI users and roles. So all of these are going to be assist this AI to complete this task. So it's a travel agent. Another AI is a traveler. They're going to be communicating with one another. And here is help arrange everything needed for flights to a hotel for 2 people from LAX to Puerto Vallarta, Mexico. Provide an itinerary for a 3-day visit, right? And then we have a word limit, which is the limit for task brainstorming. And this is the task that it uses to do the brainstorming. So create task specified agent for brainstorming. This is where we do that. I'm going to have to load everything and run everything. So that's already installed. Go. And that's very quick. That's even quicker. Let's finish that. That should now load. Okay. So here's a task. You can make a task more specific. Task specifier. Content, you can make a task more specific. Here's a task. That assistant role name will help user role to complete. Please make it more specific, be creative and imaginative. Please reply or specify task in word limit, words or less. So this is where we generate the brainstorming summary. After this is where we go in the assistant inception, so prompt. So this is the big prompt for you're an assistant, I am this other role, never flip role. So this is where you dictate a lot of the specificity for each of these agents and the way that they're going to be behaving. So there's assistant, user. So these are the prompts that initialize those type of users. This is where create a helper to get a system message for AI assistant and AI user from role names and the task. So start pulling out messages from the results. So create AI assistant agent and AI user agent from obtain system messages. Okay. And then they start to role play to solve tasks. So you can see here they start to help arrange everything needed from flight to hotel for 2 people from LAX. Specify task prompt. Okay, as a travel agent, your task is make sure that the travelers have an unforgettable vacation experience. You'll start to by gathering information about the 2 people and so on. As you can see, it starts to speak as though it's a traveler and it's an agent, and they start to speak to one another. So thank you for information. The traveler gives, based on their preference, I will arrange a luxurious beachfront suite with a balcony and an ocean view for the couple. The traveler then asks to arrange a private transfer from the airport. And then the input is the traveler will be arriving in Puerto Vallarta International at 2 p.m. on the first day of the trip. It's amazing. And so thank you for the information, the agent says. I'll arrange a private transfer. Please schedule a spa day at a nearby retreat. The travel agent says absolutely. Nearby retreat, 2nd day of the trip. And look at that. I mean, it's absolutely incredible. It's really interesting. I'll keep playing with that. And that's enough for this video. I'll make some more about how these tools are used, and I'm going to try to make some more descriptions about other LangChain functionality. But this is the latest and greatest right now, so you guys should check it out. Thanks.